All right, so let me give you guys a update and an overview of some of the plans that we're going to end up doing here for this WRX. It's a 2019. It actually has quite a bit of modifications on it already, cosmetic and some performance. Obviously, it has a Cobb access port. It has the upgraded J pipe, upgraded top mount intercooler, and has the upgraded turbo inlet. And as well, it has the turbo inlet replacement for where the boost controller goes down there, which is good. I recommend anyone that has any of these FA20s, go ahead, replace that part down there. They utilize plastic and rubber, and it just ends up breaking and deteriorating very quickly. Just takes about maybe 2 years, and it's a quick, easy replacement. So swap that out. And it also has a full turbo back exhaust, and it also has headers on it. Then also has BC coilovers, still factory suspension throughout the rest of it, but we're going to end up putting some solid end links on this, and we're raising the suspension, changing the suspension geometry. I'll be able to show you guys that within a future video, because otherwise I'm going to be explaining it for half an hour. So a couple different issues with the direct injection. So this is no longer going to be an FA20DIT, it's going to be an FA20T. We're going to switch over from direct injection over to port injection. The only benefit of direct injection is mainly emissions. Yes, you can technically run higher compression ratios, hypothetically more boost. So the best way I can explain it, there's other videos and diagrams. Typically, when the intake valve will end up opening, the piston will go down and the injector will open. It'll spray fuel down in there because that vacuum by the piston going down will pull it down in. As it ends up going up, at a certain point, typically, I don't know, it varies on a vehicle. It could be 5 degrees, it could be 15 degrees of timing. It will cause the spark plug to fire and cause the combustion cycle. On the direct injection, though, the valve will open, it'll draw air in, it'll go down, and then it'll go up. And then right before it gets up to top dead center, it'll fire that fuel injector, and it will be able to create the combustion. The issue with that, port injection, you're only running about 40 to 50 psi out of the injector. It's more or less low pressure, high flow. This, it's, damn fucking train. It's high pressure, low flow with the direct injection. Because the systems operate from the tank, yes, it will come in around 50 to 60 psi, some vehicles all the way up to 90. And then it will go into a high pressure fuel pump, which is typically operated by one of the camshafts, and it will boost it up to about 2500 psi, sometimes 1200, again, varying on the vehicle. And obviously, you guys know the valves end up getting dirty, and it ends up causing a low speed pre-detonation by any of those carbon particulates or oil, because since it's spraying it directly into the combustion chamber, it's hitting the walls, and it's not actually being able to atomize or even mix with the fuel. It's just being thrown in there, and sometimes it will cause cylinder wash. So you're going to end up consuming your oil intervals are going to be a lot more frequent because you're going to be washing the fuel. You're going to be exerting a lot more carbon deposits within inside the oil itself, because it happens on the combustion chamber too, not just even the valves. After the train went by. So those are just a few reasons. Um, Another thing is cost. For the direct injection, there's not a lot of technology or a lot of aftermarket out there for it, and it is very expensive. Just for the stage 1 and upgraded direct injection for these, which there's only one company that makes them, it's about $1,000 per injector. Where you can get a set of ID 1000s or 1050s or whatever the heck you want for, I don't know, $100 all the way up to, if you want to buy a brand new set, it's maybe $500-600, give or take what you buy, who you buy from, and everything else. So um, Another issue is with these is the turbocharger's down at the bottom. The air from the turbo comes in, goes through the intercooler, but goes down through the back here, down, up, hits this upper part of the plenum, and then gets dispersed either which out through the manifold it prefers of least resistance. So there's a lot more turbulence, a lot more overall areas of, because inside this it may look like it's hollow, but it's not. There's a bunch of passages and channels and all this other stuff. So the remedy for this is to use the BRZ intake manifold, but I'm about ready to start manufacturing parts. I'm going to do CNC plasma. I'm going to do 3D printing. I'm going to do CNC milling. And as well, I kind of do decorative stuff as well, etching of metal and wood and plastics and all this other stuff. So if you want a mural of somebody or a cool little Subaru, like I could put Subaru here and put your name on it, and like I could do that pretty much anywhere on anything, especially on the hoods. If you wanted like a mural or something, we can put a mural on here and then we can clear coat it. It'd be freaking sick. And it'll be etched and engraved in there. And I'm telling you, it's super awesome. Regardless of fact. So by using the BRZ, the FRS, the GT86, whatever the heck you use, you can either use the plastic one or you can get the wrinkle red aluminum. That's the one that I prefer. It reverts the throttle body towards the front of the engine here, and you'll have to run your intercooler piping, just a simple 90-degree with probably about a foot or two section here, and then it'll snake down. You may have to kind of reroute things, but you have actually a fair amount of room between the headlight here, and then it'll just go down to about another similar 90 with a straight, and then another 90 down into the intercooler. And then we're going to get a 180-degree bend, and we're going to put it right there. And actually, yeah. And then down into the turbocharger and so forth. We're going to switch back over to a recirculation. This is running a blow-off valve out to atmosphere. I don't recommend any vehicle that's daily driven or not going to be specifically for drag application or running high boost or manifold pressure. Reason being, with a blow-off valve, you're discharging all of the air through the system, which causes the atmospheric pressure inside of it for the map to end up decreasing. And unfortunately, by doing that, you reduce the Venturi effect through the heat and through the turbocharger, and it slows down the system. With that happening, the best way I can explain it is if you have an air compressor and you let out all the air, what do you have to do? You got to sit here and wait for it to build all the way back up. But if you just burst it just a little bit, or if you can recycle it, you'll keep the air within the system, and hypothetically, your overall manifold pressures will stay in a rough linear place rather than dropping off between off throttle or in between gear changes. So I highly recommend running a fully recirculating bypass valve, or you can run a 50-50 that's adjustable, run it more towards the recirculation side. And as well, like when building rally cars or whatnot, there's something you guys probably already know about the rocket and whatnot, which that's a similar concept but through the exhaust. Another thing that we utilize is what's called a charge box. So sometimes you can use dual intercoolers, or you can actually make a canister that's pretty much a, again, it's like an air compressor that you can discharge. You build up the manifold pressure in that particular section, and then you can utilize a recirculation valve. When the manifold pressure reaches high enough inside that chamber, it'll discharge throughout the intake track, back into the throttle body and through the engine, and you'll always have instantaneous boost. It's almost kind of like an ALS system. Now, with that being said, you can also divert that into the exhaust manifold and run what's called fresh air injection. TurboSmart has a setup that they end up utilizing, or you can run what I'm mentioning to you. I know a lot of the BMWs and the Mercedes, they're starting to utilize it nowadays because they're going smaller displacement, smaller engines, and they want to keep that turbo spooling up as much as they can. That way, so you have instantaneous response. So you think the vehicle's fast. No feelings hurt. So that's a couple options there. We're also going to swap out the radiator for an aluminum one, get better cooling, and then I'm highly considering swapping out the factory engine oil cooler for a rather than a water um, engine oil cooler. We're going to go to an air engine oil cooler. If we lived in colder climates, or this particular client, but he lives in North Carolina, and here in Tennessee it gets cold, but not too bad. The good benefit with a liquid one is it'll always keep your engine oil roughly around whatever the coolant temp is. So this vehicle would be around 181 degrees Fahrenheit. But if we ran in air, it would be whatever it could displace or disperse throughout the engine oil cooler and through the lines to cool down that engine oil. So, I mean, when you're kind of really getting on the vehicle or even just driving on long commutes or around town or whatnot, that engine oil gets real hot. And the cooler you can keep the engine oil, the better, because, again, an analogy, let's say you got coconut oil, or I don't know, you just cook the roast and you got that fat on top. What happens when you end up heating it up? The molecules, they accelerate, they span, they break apart, they turn into other molecules, either hydrocarbons or whatever happens. I'm not going to get too much into it. I could tell you guys if you guys really want to know, let me know in the comments. But um, so yeah, that's just kind of one of the things. So we're going to go with an air oil cooler. We're going to go with a front mount intercooler. We're going to go back to a recirculation system. We're going to go with a reverse mount intake manifold off the BRZ. I believe it's from like the 17 to, I don't know, the newer ones. They actually have that aluminum one on there. And I'm going to have to manufacture some spacers and adapters between the FA20 block going up, because on this one you can see you got one bolt there, two here, one on the other opposing side. On the BRZ manifold, you got one here, one in the middle, one out there, and there's a very, very slight difference on these. So you got a couple different options. You could get the aluminum spacers for this particular one and weld on another end tank for it, or you could 3D print them. I'm going to try to mill out some, and I'm going to mill 2 flat plates and then get some oval tubing and weld those in there and space it up, because especially I don't like how um, the intercooler piping kind of sits close to the belt itself, which it really isn't too much of a big deal. Um, but by manufacturing it myself, I can change the angularity on this. So I would rather pitch this manifold up just maybe 15 degrees, 10 degrees, nothing much, just to kind of give it a extruded angle out, and then I can kind of go down and around, just to kind of clear things. I shouldn't have much of an issue with the actual hood itself. This is a really nice hood that this guy has on this one, as you guys can kind of end up seeing. So we can either run sequential injection, so we could keep the direct injection in this, or we can run solely off the port injection. I prefer to go solely off the port injection. I need to kind of talk to the client, because I would prefer to run a Speeduino, but there's also some other aftermarket fuel injector control solenoids out there, specifically for this setup. It just changes the overall hertz and the frequency and the latency of the injector pulse. So honestly, I could do that through the tune. I don't really have to have the box, but if you're looking for a quick, easy way, you plug the box in, you're good to go. Otherwise, you tune it, or what I would end up suggesting go with like the Speeduino or a standalone ECU, I'm going to probably go with an ECU master for this one. That way, so I have full control. And as well, I just want things to be as reliable as possible. That way, so if we want to either batch the injectors, which I would rather run them individually, and we could keep the direct injection, run that at maybe 30% duty cycle, and then the other 70% will end up kind of pulling up from the port injection. But honestly, I'd rather just completely eliminate the direct injection, go straight to port, um, and that way, so the vehicle will run a lot more sustainably and better. There's videos on videos out there. If you want to look up direct injection versus port injection, I highly recommend you end up watching it. And if you're not convinced from what I've ended up telling you, they'll go through there and you can sit down with a piece of paper and check off the list. Maybe I'll do that here one of these days for y'all. So if we do end up running the standalone ECU Master EMU Black, I'm going to scramble the turbo, so that's going to keep it running more consistently, and it will keep the wastegate closed. And again, the fact we're running cooler air through the engine, through the intake, we're going to have cooler exhaust gas temperatures, which is going to help out a lot there. The fact that we're going to be able to cool off the block and the turbocharger, because it's oil and coolant cooled, we're going to be able to reduce the temperatures on that too. And let's say we are hammering on this, we're out on the track, whatever. When all that heat is being dispersed, we have our air oil cooler. That's going to cool down the oil very quickly. We have our thicker aluminum radiator, which again, the coolant's going to cool it down very quickly, and which is a good thing. It's not going to cool it down rapidly to where the point is going to cause a warpage or distortion, but it'll help out a lot. And then we can get rid of that piece of shit right there, which is a high pressure fuel pump, which if you wanted to do a upgrade for the DIT just to get, I don't know, they say the system's rated up to about maybe 450 factory. You upgrade it, you can get maybe 550, 650. You're going to spend almost $8,000-$10,000. The high pressure fuel pumps, $1,000 alone. As said, each one of the direct injections, $1,000. The pumps, another, I don't know, a couple $100. And then you got to get some other regulators and everything else too. You got to get a harmonic dampener for the injectors themselves. So it's not worth it. You're better off just going port injection, get you some injectors, throw them in there, call it a day, retune it, retard your ignition timing, and you'll kind of honestly be set there. I mean, change the injector timing on it. So again, when the piston's going down, have that injector open, shooting fuel down in there. And when the piston's going up, reduce the ignition timing just a bit. That way, so it's not detonating right there towards TDC, and you'll be good to go. And I'm telling you, the car will make a lot more power. It'll be a lot more happier. And I think one thing that a lot of people miss out when I've even kind of done my research into this too, is the fuel technically cools down the combustion chamber. So when you only have the actual combustion chamber itself being cooled down and not the entire cylinder, and a lot of people will complain, oh, well, port injection, it will get heated up when it's swirled through the piston, through the combustion chamber and everything. Yes, but that's what you want because it reduces the temperature, especially if you're running an iron block or even an aluminum. You don't want to have too much temperature in the stuff. You guys know how easily it'll just distort and warp, especially when it comes to aluminum. So, and just a little tip, if you ever have your car's overheating, you can use like a product named K-Seal, only K-Seal, or you can fix the overheating issue if you don't let the vehicle overheat. If the vehicle overheats, it will cause the head gasket to warp, it'll cause the cylinder heads to warp, whatever, and you will have to end up, unfortunately, removing it and have the cylinder heads machined down and timing likely done and everything else. So if your vehicle's overheating, pull over as soon as possible. Don't try to limp it. You're going to give yourself a lot more problems and headaches there. So another thing to add on, we're also going to do the 08-17 STI Brembos on this. So we'll be increasing the rotor diameter, going to 4-pot and 2-pot in the back. And I'm telling you, man, this thing and these wheels, I'm going to have, I think they're HYF down here in Johnson City. I'm going to have them powder coat these wheels. He wants it to be a gold. And we're going to go ahead and probably go with red for the caliper, something to match the intake. And I mean, this car is going to be looking sweet when it's all said and done. So I appreciate y'all watching. If you guys have any questions about your own vehicles or would like to see any demonstrations or have any information or anything out there, feel free to let me know. And if you're here near the Bristol, Tennessee area, I can always use a hand because see, my shop's a little bit of a mess right now, and I want to get your guys' opinion. I was going to build an office over here, but car space and workspace is very important to me. And yeah, I wanted to have it that way so people had somewhere to be warm and cozy, put a TV in there. But I'm probably going to get the building upstairs when it's done being renovated. So my thing was, do I turn this into an office or do I build this into a workbench area? I think a workbench area is going to be better because I can store parts over here. I can use it as a workbench. Um, and yeah, I really need storage. So I think that's going to be the better bet, especially because I have a tall clearance. And I want to move all my tools from over there over to here. That way, so I'm trying to get a 4-post and an alignment rack because I really need it for suspension geometry and doing alignments. A lot of people hate doing alignments. I love doing them. It takes me 15 minutes. I can do all 4 corners, including caster toe, the whole entire 9 yards. But obviously, got to get the money and everything for it. So if anyone has one or would like to sell me it cheap or donate it or support towards the cause, because I'd like to try to do these alignments for 60, 80 bucks preferably. And then obviously if I'm doing custom ones, maybe 100, 120. Again, it's hard to find people that do them and do them right. I remember back up there in Ohio, I had to go to so many freaking places, and the only places I could go to get it done was somebody that I knew that was actually going to do it right. And again, I know a lot of other people dealt with the same issues. So this client, he wants it done right. That's why he brought his vehicle here. This guy, he wanted it done right. And this guy's from North Carolina. He's here visiting family. And I don't know, they just want things done right. And they're tired of being swindled around or anything or left with endless options of nothing. So I don't know. I'm going to stop ranting on, but I got to call people and fix things and all that. But I thought I'd just make a little update video. If you guys have any suggestions on what you guys would like to see content-wise, let me know. I'll try to do some installation and demonstration videos, but it's difficult being the only one. So, again, if anyone's nearby wants to give me a hand or something or learn or whatnot, feel free to let me know. Take care. Have a good day. See you guys.